Hello and welcome to Selin. I'm Selin. The pun is more than intended. And welcome to today's video where I'll be covering every single topic of IB Math AASL. I'll be using black for notes and explanations. I'll be using blue for any working out and any additional questions I throw at you. So pause the video whenever you need to, write things down with me as we move and focus on understanding the process, not just the final answer. Let's get started. So scientific notation is the first topic, and scientific notation is basically a way of representing a really big number or a really small number. Okay, in mathematics oftentimes there are really big numbers that you have to work with or really small numbers to work with, and it can be very redundant to have to write all the numbers out. So scientific notation is a process wherein you represent these numbers, the same numbers, in a more condensed format. So I'll start with defining, in essence, the formatting of every single number in scientific notation. And what it is it's some sort of a non-zero number multiplied by 10 to the power of something. Okay? And there are conditions to what this non-zero number is, but for the most part, let's start with identifying a number, and I'll show you how it's basically done. So let's say we have 125 million. Okay, now let's say we were working at the mathematical calculation, and it'll be really redundant to write 125 million again and again and again. So what you in essence do is you make something called a non-zero sandwich. It's basically the first non-zero number and the last non-zero number, right? So that's our non-zero sandwich, and you will put a decimal point after the first digit. Okay, this is now your non-zero number that I talked about. Remember your non-zero number that I talked about? And in essence, you're going to multiply it by 10 to the power of a power. To find out what this power is, you're simply going to move this digit that you figured out to the end. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 10 to the power of 8. Okay, so that is your answer, 1.25 times 10 to the power of 8. This is represented in standard form, and this condensed format is now what we call scientific notation. And given that it's obviously, I mentioned at the beginning that you can work with really big numbers, but you can also work with really small numbers. So for example, if I had 0.00000527, that's a really big number to write again and again and again. So instead, you make your non-zero sandwich. You put a decimal point between the first and second digit. That is officially your non-zero number, 5.27. You multiply it by 10 to the power of some number. Again, to find out what this number is, you move backwards, right? So it's 1, 2, 3, 4, 5, 6, 7. Right? But it's not just a 7, it's minus 7, right? Because it's a really small number. If I was to say 5.27 times 10 to the power of 7, that's a really big number. But if there's a number that is less than 1, right? 0.00 is whatever, is less than 1, it would have always a negative exponent. Okay, and any in essence non-zero number that is more than 1 would have a positive exponent. Okay, these are pretty much all the basic rules that you need to know when it comes to scientific notation. Okay, and we can just do a few examples. So let's say I asked you to write 0.007211 in scientific notation, you would do the following steps. So you would make your non-zero sandwich. So that is your non-zero numbers. So a non-zero number is basically any number that is not a zero, right? So 7 is not a 0 and 1 is not a 0. And that's your sandwich. And you put your decimal point after the first and second digit. And then you move backwards. So it's 1, 2, 3, 4, right? Right? So it's 7.211 times 10 to the power of minus 4 because it's a small number, right? And let's say I had a really big number, 725,000, right? It's not that big of a number, but between the non-zero numbers, it's 7 and 5. That's your sandwich. You put the decimal point after the first two digits, and you move backwards. So that's 1, 2, 3, 4, 5, right? 5. What that means, it's going to be 7.25 times 10 to the power of 5.